Towards the end of our last class meeting, we talked about in section 4.3 these properties that sets and set operations have. We're going to talk about these in a little more detail, and we're going to see some examples of how to prove such properties. So, first property is commutative property. So A union B is equal to B union A intersect B is equal to B intersect A union B union C is A union B union C. Same with intersection. Remember, associative property was the one where you have all ors or all ands. And as you recall, there was a connection between the intersection symbol and the and symbol and the union symbol with the or symbol. It's really important to get the exact connection between these pairs of symbols, and we'll get into that later in this series of videos. Distributive laws, you'll notice they involve a mixture of union and intersection, just like the distributive laws for symbolic logic. The idempotent laws, A union A is A intersect A is A. And then there's De Morgan's laws. When I first learned about De Morgan's laws in my mathematical career, I actually learned it in the context of set theory, which is as it's written here. But there's underlying logic behind it, which is similar to how you prove the De Morgan's laws for the symbolic logic case. And then the inverse laws, the laws of the excluded middle. A union A complement is the universal set, and A intersect A complement is the empty set. If you look back in chapter 2 at the inverse laws, it might be interesting to make the observation of what the universal set and the empty set correspond with in chapter 2. So there's a proof of this distributive law in the text right after these properties are mentioned. So I'm not going to say much here about these. What I'll tell you is I think you should definitely read these in lots of detail on your own, and hopefully the example we cover later in this series of videos will help you understand the work shown in this example and the subsequent proofs. So here's one version of the proof. We won't go over it here, but I strongly encourage you to read this on your own after we go over an example together. So this is proof 1, and to prove the same fact, there is this other version, proof 2. So take a look at those on your own. If you're ready to do it now, go ahead. Otherwise, hang out for an example that I'm going to work through for you.